Okay, guys, so find the page in your packet that says observational studies at the top. All we have left to do is talk about observational studies versus experiments. So a study, you do exactly what it says. You observe people. You observe individuals, you write things down, and that's it. So it's easy to do. It's usually very affordable to do an observational study. Your results aren't always clear, though, because depending on how you observe people, like where you pick a location to observe, things like that can interfere with your results. The biggest thing is recognizing that there's no treatment. There's no like cause-effect situation, like this causes this because we observed it. Like, nope, you're just observing and writing down what you see. So there's no treatment, no cause and effect, okay? You are just observing what you see. You're not saying, you know, group A tried out a certain medication, group B tried a different medication, and then observing. None of that is in there. You're just observing what is happening right now, okay? All right, then experiments. These are a little more complicated than observational studies. So turn the page for me. This is where you're actually trying to prove a cause-effect relationship. You're using some sort of treatment like a placebo and a different medication, and you have to identify all of that and be very specific when you design an experiment. You need to have a control group when you do your design. You need to have randomization in place at some point, and the experiment has to be able to be replicated, so replication of your experiment. Completely random design is the most simple kind of basic way to do it. You have a group of subjects. That part may or may not be random, how you pick the people to be in your experiment, but then the treatments that they get, that is randomly assigned. You either get the medication or you're in the placebo group. And you have to explain, like, I flipped a coin and this determined the two groups, or I put everybody's name in a hat and I drew them out for the two groups. You have to explain the randomness part of it. And you want to be clear about what you're studying, what's being measured, what the treatments are, and like how much of each one is happening. Tell me how long this experiment is going on, and then at the end you measure again and compare those results. A more advanced way to design it is by blocking. And that is if you kind of have two groups with certain characteristics that it makes sense to separate them out. You might separate by age group. You might separate men and women. You might, there's different ways and reasons that you'd want to have blocking in your experiment. It's very similar to stratifying when we sample. Like, you put people in groups for a reason. It's the same idea here. So blocking is to experiments, as stratifying is to sampling, okay? Matched pairs design, we've talked about matching before. That's a type of blocking. You often see it with either twins or one person receiving two different treatments at different times. The shoe one is kind of a random example. You can either wear two different shoes and look at the wear that happens, or a certain treatment is being applied. So if it's matched pairs, though, the two individuals have to be very, very similar, almost identical. Otherwise, your results aren't going to make sense. Okay, turn the page. We're going to actually go through designing an experiment here to make sure you understand it. All right, so we have these researchers that think cranberry juice might be as effective in reducing a person's blood pressure as drug A. The drug A is much more expensive and has more unwanted side effects. So they want to do an experiment to see, does cranberry juice work as well as drug A in reducing blood pressure? So we need to identify a few things. So population, that's like the population of interest. Who are we looking at here? Exactly, people with high blood pressure. We're going to come back to the explanatory variable because I think that's the hardest one for you to identify. What are the treatments that are going to be used in this experiment? What do you think of? Yep, cranberry juice and drug A. Okay, response variable, that's what you are measuring. So what are we measuring? Go ahead. Yeah, it's like your X and Y. So what are we measuring in this one, guys?
Like effectiveness of lowering blood pressure.
Okay, and so we determine the effectiveness by checking their blood pressure, right? Like the blood pressure is what you're actually measuring. Yep, so the response variable is the blood pressure. Okay, so what do you think the explanatory variable is? They ended in this one, and we'll talk about that when we go through the design. I think they're just going to keep it the same. But yeah, so some of the people will do the cranberry juice. Yeah, so the explanatory variable is like what they consume, like which treatment they actually take. Okay, so it's not just the treatments; it's which treatment they take. Okay. Okay, so let's walk through how you're actually going to conduct this random experiment and how you're going to like explain that to people. So I'm going to write out the steps first, and then I'm going to actually do it just almost in pictures because I think that's easier to see like the flow through the experiment. So the first step you're always going to have to do is select your experimental subjects. And again, guys, this is the one part that might not be random, okay? Like, we only want people in this experiment who have high blood pressure. So we aren't just going to randomly select individuals for the study. So, yeah, from your population of high blood pressure people, yes. Once you've selected those subjects, what do you think we need to do first before we start any sort of treatment or anything like that? Okay, sometimes we want a control group, like people that don't get any of the medications, like they don't get the juice, they don't get the drug, they just get nothing. But what do we need to know about these people before we start giving them any sort of medication or juice? Yes, we want to get a baseline measurement. So we're going to measure the variable, which in this case is blood pressure. We need a baseline. Okay, and then we're going to randomly assign them to 2 groups. Or if you're doing it with 3 groups, you could certainly do that as well. Say this is a control group. We're just going to compare juice to the drug effectiveness, though, so we don't actually need that 3rd group with nobody in this case, okay? So we're going to randomly assign treatment groups. And now again, when you do this randomly assigning business, you can't just say randomly assigned. You have to say something like, we flipped a coin and tails got juice and heads got drug A. Like something along those lines so that you've described it in some manner, okay? So flip a coin. I don't remember what I said. Heads get drug A, tails get juice. Okay, so just be specific when you're doing that. All right, then we apply the treatments, meaning you give them their juice for their medication. And when you're doing that, you want to make sure you describe what's actually happening, like 8 ounces of juice 3 times a day, or 1 pill per day. Like that information should be given to you. We don't really have it in this problem. So we'll just pretend, let's say 8 ounces of juice. I don't know, we'll do 2 times per day. Or 1 pill per day. Move it up a little bit, sorry. Okay, so this has happened over a certain amount of time, and hopefully that's given to you in your problem. And say we do this for like 3 weeks. You know, tell me the time period that you're doing your treatments. What do we do at the end of those 3 weeks? Yeah, we measure the blood pressure again, right? So for us, that's measure blood pressure. And then the last thing you can do is compare those results. So did it show, you know, significant improvement with the juice compared to the medication? What have we done all throughout the year to like make comparisons or look, was there enough evidence to suggest this? Yeah, so at the end you can do a hypothesis test. So that's how you make your comparison. So with this, I mean, none of this is really super hard and complicated, but it's tedious, right? Like it's just a lot of details to write out. Let me show you, I don't really have enough room in this little spot right here. Let me draw for you what this might look like if you just did it by pictures, you know? So I've got a little box over here. I'm going to select subjects. So those are my people. Thanks. with those people, then we're going to measure, and I'm trying to write up here, measure their blood pressure. Okay. From there, then we're going to split them into our 2 treatment groups, right? Measure BP. Sorry, I was trying to write up. That's hard to do. Did I say tails was the juice and heads was the drug? Is that what I said?
Would you?
Yeah. Have a good break.
Yeah.
Would you randomly assign them first, but not finish the testing?
You could do it either way. Yep. So you could measure right here, or you could randomly assign and then measure. Yep. Totally fine as long as you specify somewhere like, I'm measuring this before I give them their treatment.
So like you could like write in the steps they split them into groups and then test
Yep.
for BP and then
Totally fine. Yes. Yep. Good question.
is that like sufficient to like tell the order?
Yep, definitely. All right, so I've got juice up here, and we were doing 8 ounces 2 times per day. That's what we said. And I know I'm squeezing that in. Then we had drug A, 1 pill per day. And just describe in here your random assignment, Yanni.
Maybe want to start in the exam and tell you what our blocks and
No, blocks is different. This is this is me doing this. I just didn't have enough room right here. Blocking will look different. Because with blocking, we'll put them into like subsets for a reason from the beginning and then go through the experiment. Okay? I'll draw that one too. So I think we said tails. Oops. So flip coin or random assignment. This was heads, this was tails. Okay, and then let's say 3 weeks goes by. Oh, did I? I'm sorry. Thank you. I asked and then I still mixed it up. Thank you. All right, so 3 weeks passes. What do we have to do next? Like test their blood pressure again, right? So measure BP. And then finally, we're going to look at these together and make a comparison. So compare. So you can list it all out, like bullet point your way through your steps of your experiment. You can draw it out like this if this makes more sense to you. Just be detailed with it, whichever way you do it. Mm-hmm. As long as you're very specific with, you know, you probably want to tell them like, these were my subjects and this is how I decided random assignment, but like most of it can be just in your picture. Yes. Okay. Questions on that? Yeah. Oh, yep. Yeah, I'll give you some time. Mm-hmm.
Could you label like that little man and help in your calculation and then just find what that is?
Absolutely, yeah.
Okay, and then would that be specific enough for the team?
Yep. Yep, I like it. Are we good? Ainsley, you good? Okay. All right, so that is just a basic, completely randomized experiment. So let's say we want to conduct the same experiment, but we're going to add blocking into this experiment. I'm going to do just the picture part first. We don't need to rewrite everything that we did in the last one. So again, we have our subjects. Yeah. So you can define it, or like what is a block-in just in general? Oh, it's a group that you create for a specific reason. Like if you think your medication might affect men and women differently, you want to block by that. Yes, yes. Maybe you think like this medication works better on a certain age group, then you probably want to block by age group. You know, just you've separated them for a reason. So that part isn't random. Okay. So again, you still start with your experimental subjects here. So same people. And usually you'll know how many, like you might say, we have 300 subjects for this experiment. So if you know that, include that in there. Okay, we obviously were not told any information about that. All right. I'm going to block first step here. Block. And again, this part is not random. We're doing it for a very specific reason. So I'm going to group female and male. Okay, I'm going to group by gender. And once you've done your blocking, then it's exactly what you did before in the completely randomized experiment. You're going to measure the blood pressure. You just kind of have to write everything twice now. Then you're going to randomly assign them to their two groups. We've got our juice group, 8 ounces, 2 times daily. We've got our drug A, 1 pill per day. And then you have to do the exact same thing down here for your male subjects. Juice, 8 ounces, 2 times a day. Drug A, 1 pill per day. This was random. And again, let's see. What did I do? Tails for juice. So you want to include that. Like tails here, heads here. You've got your 3 weeks. What do we do after 3 weeks? Measure, and our final step is to compare, okay? Yeah. Yeah, like, would you have to, like, do the hypothesis test that we were asking, or?
Yeah, like if that.
Yes, it's unlikely that you're going to get a question that makes you design the experiment and carry out the hypothesis test. It could, like, that is a thing that could happen, but it's very unlikely. Usually you're just, if it's an experimental design question, you're just going to design the experiment. Yeah.
Would it make sense to like draw out a comparison between the two blocks or
It could. I mean, it could ask you something about that, and then it's like, was this drug more effective for men or women? Then you'd want one more little line to one final comparison box. And so, guys, I didn't, since we did the same thing as up above, I didn't write out everything with, you would flip a coin for heads or tails, but you get the idea of it here. That's just the difference between blocking and not blocking on an experiment. And I know this is a little messy, so if you can't read something, please ask. Squeezing it in there.
what instances would you choose to block? Like any of the guys like
Oh, to do this?
yeah, just like when would you choose to block it?
It completely depends on what it is that you're testing. It all has to do with if you think it impacts groups differently, whether it's a medication, whether it's a fitness plan, whether it's like whatever you're trying to show some sort of change because of a treatment plan. If you think like group A over here, it's going to work way better with them than it is with this group, you maybe want to block so you can see the difference there. So it all just depends on what it is that you're trying. Yeah. You could, yeah. Yeah, like say it was by age group and you had like, teenagers and young adults and old people. You can do it either way. Like if you run your experiment and you start noticing like, oh, well, okay, these results are interesting. Then you kind of need to start over with a new experiment with blocking. Does that make sense? Okay. Those are good questions. Anything else, guys? Okay, we're gonna do, I've got a worksheet which is some multiple choice practice on experimental design and sampling. And then that's all we're doing today, okay? That's the end of your notes, guys. That is your last notes for the year, so that's kind of weird. All right, so let me stop this.